Let's take a look on this problem. Problem 1, calculate the moment. So we, from a note that I show you, so we have moment always equal to force. Usually we say that one is F multiplied by D is the distance, usually in D. So as long as you have the force multiplied by distance, the distance over here is not the normal distance, this is the perpendicular distance. Okay, perpendicular distance. All right, so let's take a look on each problem over here so you can get a better idea how to calculate moment. We have the force here. This one is the force. The force here is 5 pounds. Perpendicular distance. Perpendicular distance is the point over here. From the point, you draw the line so that it can be perpendicular to the force. And that is the perpendicular distance. And we know that this one is D. Okay. So the moment in this case, moment of A we equal to 5 multiplied by 7 equal to 37 or 35 pound foot. Okay. So the answer of question A over here, that one is 35 pound foot. Not difficult, right? So now let's check question B. Let's copy question B over here. So we have the force over here is very easy to see that one is 5 keep. However, the perpendicular distance, is that 7 or is that 5? Which one? Let's think about that first before I show you the answer. Alright, so how can you answer that? You just draw a line from the point over here perpendicular to the force. So if you draw from here to here, then it will be parallel. You cannot get the perpendicular distance. Okay? So this line is not correct. So then we need to extend the force over here. So extend the force over here to make it longer. And then you can draw a line from here to here. Then you get the perpendicular distance. So the perpendicular distance is the red one over here. So that is 5 feet. So we have the moment at A here we equal to 5 keep multiplied by 5 feet. This one equal to 25 keep foot. If you want to convert the keep over here to pound, you can do that as well. This one will equal to 5 keep equal to 5,000 pounds multiplied by 5 will be 25,000 pound foot, and they are just the same thing. Now let's check question C over here. Question C, maybe let's move it here for easy to view. So we have the force is very easy to recognize. The force is 5 pounds. So now we need to check the perpendicular distance. So first, you put your pencil into the rotation point. Rotation point is A over here. And then you draw a line that is perpendicular to the force. If the force is too short, then you can just extend it. Just extend it over here. Then you have the perpendicular distance is the red line over here. How long is that one? That one is 27 inches. Okay, so the moment at A equal to 5 multiplied by 27, and this one is, maybe let me put the unit over here, 5 pound multiplied by 27 inches. I will have 135 pound inch. Now let's check question D over here. This one is not a straight line. It have an angle. So we need to do additional calculation with this one. First, you need to know what is the perpendicular distance from the rotation point A over here to the force. The force here. So if you select from here to here, that is not perpendicular. Right? If you select from here to here, that is not correct as well. So what I tell you previously, first thing is that if the force is too short, then you just extend it to make it longer. And then from now you can draw the perpendicular distance. So the distance is actually, this is D over here. The question is, how can we calculate D? This one we need to apply trigonometry a little bit, sine, cosine, and tangent. So we have the angle over here is 60, right? So you just remember for me. So ca toa. So is opposite, and then the hypotenuse. So this one is the opposite, and this one is opposite is over here. Hypotenuse is over here, right? Because opposite to the angle, opposite. If you take if you have the eye over here, you see that this one is the opposite of the angle, right? So we know that. Let me clean this one a little bit so you can see it clearer. So we know that sine of 60 equal to, so opposite divided by hypotenuse. Opposite is the one we need to look for. We don't know. And then hypotenuse is 7. So if we want to find opposite, then we let sine of 60 multiplied by 7. We have the opposite. So this one over here, which is equal to sine of 60 multiplied by 7. And you can put that into your calculator. I'm going to do that now. So sine of 60 multiplied by 7 equal to 6.1. 6.1. So the distance is 6.1. So we know that moment equal to force multiplied by distance. Force we have here is 5 keep multiplied by distance is 6.1, and then we have that is 30.3, around 30.3 foot keep foot, or foot keep, the same thing. Okay, now let's try problem E. Problem is just the same thing. Let me delete that. Problem E, just the same thing. So the first thing is that you need to extend the line over here and then draw a perpendicular distance. This one over here is D. Question is, what is D over here? So you over here you can use psi as well. So psi of 45 equal to opposite is actually D. Divide by hypotenuse. Hypotenuse from here to here, we already know that one is 10 feet. So D will just equal to 10 multiplied by 45. Psi of 45 equal to 10 multiplied by psi of 45. We will have this one equal to 7.07 feet. Okay. Let me write clearer. 7.07 feet. Okay. So the moment is very simple. Moment we equal to force. The force is a keep multiplied by the distance is 7.07 feet equal to 56.56 foot keep